Bangkok, and I'm just delighted. I'm absolutely amazed. One of the things the city has is the ambiance has just been absolutely none like any other. The topic is nutrigenomics. It's an integrated approach and use with bioidentical hormone replacement therapy. I really want to make you understand that when I updated this lecture, I really realized just how much I really didn't know about nutrigenomics in combination with BHRT, because every year, the more I go into it, the more things emerge. And so what I really want to accomplish for you today is to understand the flow. I don't want you to get overwhelmed with all the nutrients and which nutrients. That comes in workshops. But what I want to really put forward and just introduce is a concept of just how important nutrition is in use with bioidentical hormone replacement therapy. That is the key thing in today's 25-minute lecture. It's too short to cover all the nutrients or how to implement it. But if you understand in today's lecture the concept, you will understand then how you can provide added insurance to your patients when you're using bioidentical hormone replacement therapy. And I think that's the key. We want to do it as safely as possible. And I don't see any other way except this way when I prescribe hormones. It's defined, it correlates the effects of nutrition to the expression of genes. It focuses on identifying and understanding molecular level interactions between the nutrients and other dietary bioactives within the genome. So in other words, you can change the way you affect your genes. You may not be able to change the genes, but we certainly know now that we can change the way we express those genes. And it integrates with bioidentical hormone replacement therapy because the hormones stimulate selective gene expression to induct a response and can be metabolized then to DNA adducting products, thus changing the genomic expression activity. And what this means is that if you change how you metabolize the estrogens or progesterones or any hormone, you can then really selectively affect that at the genetic level. And we use the nutrients to do that. So going on to the right side, where I'm going to focus on estrogen receptors, before I go into this slide, I want you to understand that there are two types of estrogen receptors: estrogen alpha receptors and estrogen beta receptors. And unfortunately, we think that it's like all estrogens equally affect the estrogen receptors. That's not true. What I came to learn when looking at all of the research is that estriol has usually about a 4-to-1 affinity, 4 times higher affinity for estrogen receptor beta sites. And estradiol and estrones have a higher affinity for estrogen receptor alpha. This is a very key point as I move forward with this. So nutrigenomics to bioidentical HRT is there are now identified dietary and supplemental based regulation of hormones induce gene expression and may do so selectively. You can alter metabolism of hormones, inhibiting the potency of many gene-altering derivatives. So what do you target? You promotion of compounds that downregulate high cell proliferation rates in response to ER induction. So in other words, we would want to have promotion of compounds that would downregulate more at the nuclear level, or that they would have no effect there, but actually help at the membrane estrogen receptor level. So one such compound is indole-3-carbinol. Indole-3-carbinol goes to DIM. It's one of the 3 metabolites of indole-3-carbinol, DIM is. And DIM is di-indoyl methane. So indole-3-carbinol is plant-derived component of cruciferous brassica vegetables, broccoli, Brussels sprouts, cabbage, cauliflowers. It's been studied a lot at the National Institute of Health. In fact, there are analogs being made right now for the prevention of breast cancer. And this is, again, another example of how nutrigenomics is being used so readily by pharmaceutical companies. They're understanding the potential of just how important nutrition is. So, in the presence of adequate stomach acid, indole-3-carbinol undergoes formation into several significant products. The observed to affect estrogen metabolism by altering the activity of phase 1 enzymes. That's at the liver metabolism level. But I want to show you how it actually acts on the receptors. So in the presence, again, I'm going to say of adequate stomach acid, three significant products is HNTI, and that binds to estrogen receptors and shows chemical structure similarity to tamoxifen. So it is a beneficial product. And you have DIM, of course, and ICZ. The reason I think indoflucarbinol is important, is because you can take advantage of these other two metabolites. John Hopkins, there's a research is showing more towards DIM because they recognize that a lot of people are on proton pump inhibitors, so they don't have the adequate stomach acid. So they may not be able to break it down into the three metabolites, hence just give DIM directly. I think in my practice, it's a combination approach to use both because you want to take advantage of the other two breakdown products as well. So DIM triggers estrogen receptor beta-mediated transcriptional pathways rather than estrogen receptor alpha-mediated pathways. The activation of ERB by DIM may also be linked to DIM-mediated activation of the transcription. Another really interesting paper showed there was lower concentrations of DIM showed to decrease proliferative rates in MCF7 cells and induce high levels of apoptosis when concentrations were increased. MCF7 cells are cancer-causing cells. So these observations were correlated with a DIM ligand-independent activation of estrogen receptors. So you can see, this is just an example I wanted to give you of how much literature is out there with just one or two nutrients that can actually affect estrogen receptor. So when you talk to your patients and you want to try to tell them why bioidentical hormone replacement therapy is safer, you can tell them that estriol has a higher affinity for estrogen receptor beta rather than estrogen receptor alpha. Hence, it's safer. Now, this was a really interesting. JNK it's a response. It's kinase that phosphorylates CJUN, and what it is involved with colorectal cancer as well. And JNK responses is known to contribute to inflammatory and pro-apoptotic responses. So what I'm getting at is that JNK is involved when estriol promotes this JNK, which means that it contributes to inflammatory and pro-apoptotic responses to a good thing. And so does DIM. And again, you can see their associations just on a continuum of colorectal cancer and estrogen metabolism and receptor metabolism start to emerge here. So this is activated by the membrane at estrogen receptor beta induction and inhibited by estrogen receptor alpha induction. So in other words, if you had a lot of estradiol circulating, you're going to get more estrogen receptor alpha activation, which could go and inhibit JNK, which is not what you want to do. That's why you want to have more estriol rather than estradiol. In another paper, these are great cancer publications. I mean, this is something I felt that I should have known about much earlier. Estrogen receptor beta expression significantly decreased E2-induced cell proliferation when compared with cells expressing only estrogen receptor alpha. So again, what this is saying, this slide is saying is that a lot of it is, if you have estrogen receptor beta expression, you really decrease the risk of estradiol-induced cell proliferation. But if you have expression at the alpha receptors, you can actually promote their proliferation. So enter now some other nutrigenomics. So you have EGCG, which is one of the components found in green tea that's observed to inhibit growth of breast cancer cells. Vitamin D3, uptake from the sun exposure dietary sources, again been observed to inhibit cell proliferation, and mild inducement of cell apoptosis. And ellagic acid is very interesting. It's a natural antioxidant found in many berries, especially the black raspberry. Blueberries don't have very high concentrations of ellagic acid. So that's a misnomer for people to just say ellagic acid is found in berries. That's not true. It's very small amounts. You have the studies show about 400 parts per million of ellagic acid if you have it, and the maximum is found in pomegranates and black raspberries. So it's a natural antioxidant found in many berries, other fruits. Vitamin B12 known to be involved in DNA methylations. And in other words, the more you have methylations the better it is against cell cancer risk, the methylating reactions. Again, a paper showing that EGCG suppresses E2 stimulated activation, proliferation, and vascular endothelial growth factor expression of endometrial cells. And this was the regression of endometriotic lesions was an in vivo study. So I thought that was very interesting. And how this is accomplished is thought to be competitively binding to estrogen receptors, because what ellagic acid will go and do is when you have high levels of estradiol circulating, it'll go and cause competitive inhibition. So it'll bind up to the estrogen receptor, actually the beta, and even some of the estrogen receptor alpha, which is actually what you want to do, ellagic acid to do, thus downregulating the effects of the high concentration of the estradiol. Here's a vitamin D paper, 125 dihydroxy vitamin D, a steroid hormone derived from D3, is a negative growth regulator of ER-positive breast cancer cells. Co-treatment with resveratrol, phytoestrogen, enhanced growth inhibitory effects of 125 vitamin D, giving evidence that such dietary factors could negatively impact the formation and maintenance of breast cancer cell lines. So resveratrol, I'll present tomorrow, actually works at the quinine reductase enzyme of the estrogen metabolism pathway of the liver. Again, more research is showing vitamin D is a promising anti-cancer agent. Ellagic acid was observed to downregulate the E2-induced expression of the HTERT protein. HTERT protein is a common biomarker for the onset and progression of cancers. And the downregulating effects of ellagic acid on HTERT I thought it was pretty dramatic. It may imply its involvement as an anti-carcinogenic compound via the estrogen receptor pathway. So again, just shows you how estrogen receptors are being affected by nutrients. This is a very powerful thing, because most of the time we just think nutrients, we think we have a great diet, we should be able to not supplement and take everything through our diet. Well, have any of you checked to see when the last RDA requirements or RDA values were checked? We're going by RDA values of foods that were done about 25 years ago. No one's doing RDA values now. The food quality has changed dramatically. So we're not getting all our nutrition. Even though we're eating black raspberries, we may not be eating sufficient amounts of it. So in my opinion, I think it's very important that nutritional medicine, the knowledge be known, because we have to immerse ourselves as actually recommending to our patients. This is why we supplement. We have still the conventional thinking that if I just eat right and exercise right, I'm not going to get sick. But that's not true. We just found out, Serena Williams, I just heard, I think it was Venus or Serena Williams, one of the tennis, had an autoimmune disease. Why are we suddenly starting to see autoimmune disease emerging and cancer emerging? Because our immune system is being affected, and a lot of it just has to do with nutrition. So I want to talk a little bit about the folic acid results. A lot of times we hear about how folic acid can actually cause cancer. And in a way that's a true statement, and let me explain. When you have dietary folic acid, and you have lots of folic acid coming in through to the diet, you have to be able to break down that folic acid to 5-methyl tetrahydrofolic acid and 5-formyl tetrahydrofolic acid. If you can't break it down, that folic acid actually goes through a reaction of oxidizes. And that's the potential for that risk. So if you have a breakdown product of folic acid, that's very beneficial. And if your body can do it, that's great. But we know that a lot of us, or in the population, lack that 5-methyl tetrahydrofolic acid reductase enzyme. So we're not being able to break that down. And that's why I think the controversy exists on folate. Natural folate is what I call the ability to break down folic acid. If you have that and you're able to take enough amounts of 5-methyl tetrahydrofolic acid or 5-formyl tetrahydrofolic acid. In fact, nutrigenomic companies have picked out on it. Pharmaceutical companies have picked up on this nutrient. Deplin is the medicine used for the treatment of depression because you can get methylation. It's a breakdown product of folic acid. They realize that. Another Meta-NX is being used for the treatment for diabetes. Look these medicines up. They're nothing but nutrigenomic substances. I tell my patients these are the best medicines I could prescribe to you. Pharmaceutical, I write a prescription for them. Patients with SSRIs, I use Deplin in conjunction, fabulous results. Why? Because it's a nutrigenomic substance. I wanted to mention here about the polycyclic aromatic hydrocarbons. These are sort of part of the family of PCBs, polychlorinated bisphenols, all of the estrogen mimickers, because we're going to start seeing so much more. My recent quest on that was, and I discovered, was flame retardants have PDBE, which is an estrogen mimicker. So babies are now sleeping on mattresses, which at least in the US we have laws that you have to have flame retardants in your mattresses. And these are estrogen mimickers. And so we're starting to expose our kids, babies, to estrogen mimickers. It alarms me and it surprises me that companies that have billions of dollars for research can't come up with pesticides or flame retardants that don't have to mimic estrogens. It just alarms me. And the reason I mention this is because this is a potential toxin. If your liver can't handle it and metabolize this, detoxify it, it can potentially go and form a sort of what we call bad estrogen. We know that there are good and bad estrogens. I don't have to even talk about defending that. My earlier slides used to show that. I don't show it anymore because New England Journal of Medicine already in 1992 was talking about this. So we have our conventional medicine talking about it, but we never paid attention to it. We simply just assumed everything goes to estradiol. So here, our xenoestrogen exposures is becoming huge in the interplay of our toxin exposure to estrogens. And this is just one example of how polycyclic aromatic carbons exhibited weakly estrogenic responses, and effects of pHs give evidence of genotoxic roles. Absolutely, they're genotoxic. Other nutrigenomic factors, vitamin B6, zinc, CoQ10. I don't have time to go into these in detail, how they would express. I would love to do that. Time is my limit. Omega-3 fatty acids, curcumin, 5-methyl and 5-formyl tetrahydrofolic acid, sulfochrome, calcium D-glucuronate, and many others. I hope I put zinc in there. So what is the role of nutrigenomics in bioidentical hormone replacement therapy? We know, I hope that at the end of this lecture you're able to really understand that nutrients clearly play a role in regulating the response and potency. A response due to hormonal actions, emphasizing the need for proper nutrient supplementation during BHRT for effective and preventative therapy. Future studies and focus should be directed towards the mode of action and targets for prevention of negative side effects associated with BHRT. And I think it's so important to, again, emphasize here, this is your added insurance, because when I add these nutrigenomic substances with my patients, even their results are better, they're feeling better. I don't have to even increase and go to higher doses of using even hormones sometimes when I synergize my regimen with certain nutrigenomic substances.
Well, thank you very much indeed. A fascinating lecture. Can we show our appreciation, please? There must be questions from the audience, surely. Probably one of the most important presentations of this entire conference. I hope it stimulated a great deal of thought. It conjures up in my mind just how naive we are when we talk in a simplistic way about hormone replacement therapy, and we convince ourselves of the safety and efficacy of bioidentical hormone replacement therapy without really considering the ratio of actions and receptor interactions of even a simple sex hormone or one subtype of estrogen. Naina, I think you've just given us the highlight of this meeting, and I hope to hear more about this subject, which goes beyond.
Wait till update next year.
Beyond, but there again, I don't want to show my eccentricity. Thank you very much.